I think we're recording. Yeah, it looks like we're recording. Okay. All right. So, Dayla, just for you, look at this. I've got a 12-page final review for you. How's that? How's that? Now, I even gave you 25 questions, but I've only got answers for the first 7, so about 1/4. Well, it won't do any good. So here's what I'll do. So this is, you can think of this as a rough draft. It's posted on Canvas. We can, yeah, I'll try to get the answers later, or you can text or email me. So yeah, anyway, so. Yeah, I have a 7 a.m. final on Monday. Ugh. All right. So I'll just leave those are the first 2 pages there, roughly. Is there anything that you would like to talk about on those first 2 pages? The first question, what's the difference between confidentiality and anonymity?
If it's confidential, you just keep it, like you know who they are and the information versus like.
Okay, so, and I'm going to repeat because I got a bad microphone today. It's good for me, but we won't be able to hear any of the questions in the class. So you said if it's confidential, you know who they are, but you're keeping it private. And if it's anonymous, you don't know who they are. Okay? Very good answer. That's correct. Okay, high five.
Yeah.
All right. So what other questions on there? Do you want to review? Realize we got, I guess we don't have 12 pages. I don't know how many pages of questions I have, but several. Or do you want to look really quick? The sample questions start on page is that? I think that's page 7. Okay, so 6 pages of review and then 6 pages of sample problem. That's pretty good. Okay, so let's go back to page 1 and 2 there. Is there anything you would like to review on that? These are not in any particular order, by the way. They're just kind of scrambled. What is IRB? First of all, what does it stand for? Institutional Review Board. Did you guys all do your quiz? Okay, I need to grade that. The IRB quiz. You did do that? Okay, so IRB stands for Institutional Review Board. What does it do? What's its purpose? Protect the patients. Do they care whether you have a good statistical study or not? They do not care. It's not their purpose.
Is it basically just to do like the most ethical, most safe thing for the patient?
Yes, it's to do the most ethical, the safest thing for the patient. That's their job is to protect patients. They don't care about your study, other than will it protect my patients? Okay. They're not there to check your math. They're not there to check and see if you did a good study. Their purpose is to protect the patients. It is on Canvas. I just barely loaded it up minutes ago. Okay. What other questions do you want to go over? Yes, Kristen. What is under coverage? Anybody know?
Didn't get enough coverage.
You didn't get enough coverage from something. Okay. That's actually right, but how does it apply in a statistics context? Excuse me. That would be the better question. How does that apply? Robert?
You can't get an accurate information because you don't have enough to pull from.
Okay, you don't have enough accurate information because you don't have enough information to pull from. So that's correct, Does that make sense, Kristen? Let me ask that first question, what he said. Okay, so how does it apply to statistics? Why don't you have enough information? I'll ask it that way. Because you don't have enough responses. Okay. How could you counteract that problem? Ask more people. In what kind of a sample? In a simple random sample? Actually, no. What kind of a sample would help you prevent having problems with undercoverage? Not a convenience sample. That is correct. Not a convenience sample. But what is it? What kind of a sample? Voluntary response sample would be another bad one. What? Well, the census, yeah, you're not going to have a problem with undercoverage in the census. Most often we don't do censuses unless we're in school, right? And it's easy to just pick everybody in the class. What would be another sampling method that would help you overcome problems with undercoverage? Begins with an S. Stratified. Okay, very good. It's a stratified sample. Okay, so you could stratify on what? What would be some examples of stratifying so you don't have problems with undercoverage? No idea. That's the wrong answer. Not having enough information on people you're trying to study. Okay. So what's an example of a stratified sample? You make some groups such as males and females. If I did a simple random sample, I could get 30 males and 10 females, right? So do you think I'd have a problem with undercoverage on female opinions? Okay, so I might want to break that up so that maybe I'll try to ask more females to get my sample size bigger, right? What are some other ways that you could stratify? Degree, no degree. You guys are always thinking about school. Okay. What about like real polls? They don't care whether you, well, actually, we do know that Donald Trump got more of the no degree people than the degree people, right? That's another thing you can do. If you stratify your sample, you can break down into subgroups and figure out differences like that. Age might be a good thing to stratify on. You don't want too many old people, too many young people, right? If they're married or not, have kids, okay? Does that make sense now? Dayla, do you understand undercoverage? I hope so too.
Undercoverage, you can stratify samples to get more data.
To avoid undercoverage, I'm going to just repeat what you said because I know that you won't be able to hear it unless I repeat it. Okay, you can scream. Okay, we don't want anybody, police coming in here thinking there's a problem. Okay, so say that again. To avoid undercoverage, you can use stratified samples to get more data. More data from the subgroups.
That's correct.
That is correct. Okay, so you don't have too many men or women, you don't have too many poor people or old people or young people or whatever, okay? So that helps you with problems of undercoverage. Okay, what other questions do you have on those first 2 pages? Minimal risk. What's minimal risk? You should have learned that on your IRB quiz. Did you remember anything from that thing, or you just took the quiz to get it over with?
That's confidential.
That's confidential. But it is anonymous.
And in what sense do
What is minimal risk? Low risk. Can you give me an example of what a minimal risk experiment might be? I didn't hear what she said.
I really don't. No, that is not minimal.
Yes, it is. It doesn't do anything to you.
Pricking your fingers to see your blood type?
Yeah, that's minimal risk. Nothing can happen. All you can get is a pill.
Or you use your needle and get AIDS.
Well, you're going to set proportion. Okay,
Or you
change that.
have a blood clot.
See what the
Well,
effects are.
let's do this. Let's say it this way. Okay, because I know we didn't hear that little back and forth. So pricking your finger, is that a minimal risk? One person said yes, one person said no. You could use a dirty needle and get AIDS or something like that. Okay. Well, let me just say this. If you wanted to prick your finger in my class, you would have to get IRB approval. Okay. But most cases, that's not a risky thing. Well, so the idea with minimal risk is you're doing it for the purposes of a study on humans. If you're doing it in your biology class, it's probably to learn something, so the different rules apply in that case. So so minimal risk and associated with the IRB. So let me give you some examples. Let's say I'm trying to think of a good example here. Oh, this was an experiment my group wanted to do. Would you say that this is minimal risk? Okay. So my group wanted to do a study to see, they would just stand near a door and they wanted to see if when people walked in the door, if they held the door open for the person behind and then the person said thank you or not. Would that be an example of minimal risk?
I don't really know what it means yet, but I think so.
Yeah. You're not, are you causing any risk to the participants? They may not know that they're in the study, right? They're just doing their normal thing. But that would probably be approved because that would be minimal risk. There's no risk to the patient. Okay, let me give you another example. Tell me if you think that this is minimal risk. Let's say, this is actually an example out of the book. I can't remember if it was a problem I assigned, but it was in the old book, I know that. I always thought it was a weird experiment. Experimenters want to study personal space. So they want to set up a camera in the men's room and they want to block off a couple of urinals so that two men have to stand next to each other while they urinate. And they want to time how long it is when they're standing alone versus when they're standing next to somebody. Would you consider that minimal risk? Okay, probably not, right? That's called an invasion of privacy. You can post those videos on YouTube or some other site. Okay, so would you approve that experiment if you were on the IRB? No. What if, so that would probably be not an example of minimal risk. What if, well, let's take, I don't want to pick that one. Let's say you want to poke somebody with a needle, get a vial of blood, and you want to find out how much protein or red blood cells or whatever is in their blood. Would you call that minimal risk? You'd call that minimal?
You're not hurting them.
You're not hurting them. How about a spinal tap? That would not be minimal risk. Now, so as far as minimal risk, it can kind of depend, I guess, a little bit on the situation. If you're a hospital, pulling a tube of blood on somebody's would probably be considered minimal risk. You're trying to, do something. If you're doing a spinal tap, certainly that is not minimal risk. That's high risk. Or an epidural, like if we were doing an epidural for a study, not just, a woman's pregnant and doesn't want to feel the pain. Okay. So, so does that help you understand minimal risk, JC?
Yeah.
Okay. All right. Okay. What other questions do you have? I can't hear you.
Who can consent? Is it just
Who can consent? After this question, we're going to go to the next page and then we'll keep cycling through. Who can consent? Is it just over 18?
No, those with Alzheimer's.
So those with Alzheimer's might be hard to consent. Mental disorders would be hard to consent. Children would be hard to consent.
Everyone except for people with medical disabilities.
Well, we should also mention vulnerable populations.
In my notes.
Okay. What about in your notes? What does your notes say?
Children can't consent.
Children can't consent.
Remove consent at any time.
Can remove consent at any time.
People with mental disorders can't consent.
People with mental disorders can't consent. Heart and Alzheimer's. Oh, there's one that's missing that I was just going to mention. Okay, so this is a true story. When I was up at the University of Utah, they wanted to do a study on mental health of prisoners. Would you say that prisoners might be a vulnerable population? Okay. Now, true story. I'm pretty sure I told this. I think it might have been the first or the second day of class. You know, when they did we talked about the polio vaccine, didn't we? Okay. Jonas Salk was the guy who invented the vaccine for polio. That was before the IRB rules existed. And they actually said, oh, let's test it out on these orphans over here. Nobody will care if they die. They're orphans, right? Would you call that a vulnerable population? Yeah. Okay. So prisoners, you'd have to make sure that it's truly consent, or because it could be coercive. Oh, we'll let you out of jail sooner if you participate in this study. Would you call that coercion or improper? So, yeah. So there was also the syphilis study that I think we talked about on the first or second day of class. They took a bunch of poor black sharecroppers in the South and did a syphilis study on them. And then even after penicillin came out, that was a known cure for syphilis, they purposely didn't treat these poor black men and let that disease just progress. It was awful. Okay. So the IRB, I mean, this kind of goes back to IRB is important. It's important to make sure we worry about vulnerable populations. Those black poor sharecroppers, they didn't understand. They weren't given informed consent. So it's not just those that I listed. You should make sure that all vulnerable populations are okay, such as poor people, illiterate people, things like that. Okay? All right, let's jump on to the next couple of pages just so that we get plenty of time and we don't concentrate too much on here. What on those 2 pages, so is there anything you guys want to talk about here?
Can we go over just how to make a histogram again?
How do you make a histogram? Good. Okay, we haven't done that for a while. Oh, yeah, some of you didn't do it on your projects either. Okay. All right, so what'd you say? Do we aggregate the data for a histogram? What do you think the answer to that is? Dayla thinks it's yes. Who agrees with her? Nobody agrees with her? Who disagrees with her? Nobody disagrees with her? What does aggregate the data mean? Okay, we got some data here. Big. We're just going to use a bunch of random numbers, okay? Rand between, Kristen, pick a number, any number. What'd you say, 21? And Brock, pick another number higher than 21. 6,000, wow. All right, so we got a bunch of data here. Copy, paste special. Okay, so this is our data that represents who knows what. Okay, how do you make a histogram? What'd you say? Yeah, there's a histogram maker and it's illegal to use on my test. You forgot.
You make a bar graph and then go to We have to like do like thousands and 2,000.
Thousands and the 2,000s and the 3,000s. What's that called? Aggregating our data. That's exactly right.
Isn't it gonna do it for you?
Okay, so since we did that, so no, well, it could do it for you, but I want you to do this by hand. Okay, and the Excel will do a crappy job of it. In fact, I'll show you that ours will look better than Excel's. Okay. All right. So what are the groups? How many groups should you have?
Less than 7.
5 to 7, right? Okay. Now that's for my class. You can have as many as you want when you get real data, but I'm not going to have you, do 10,000 pieces of data, even though that's what Brock wanted me to do. Okay. So for our test, let's plan on 5 to 7, but in the real world, you can have as many as you want, whatever makes sense. Okay. So what would be some good groups to do? The hundreds? 0 to 999, 1,000 to 999, 2,000 to 2999, 3,000 to 3999. Well, you know what we could do? Maybe we should do it this way because we could get a 6,000 in there, right? And I don't want to start a new group at 6,000. Let's go, because we're not going to get a 0. Let's go 1 to 1,000, 1,001 to 2,000, 2,001 to 3,000, 2,001 to 4,000, 4,001 to 5,000, 5,001 to 6,000. Okay, so then if we get a 6,000, it won't bother us. Okay, now what?
Now you get them on its side.
Do what? The history.
Put the numbers.
Now we need the count,
Copy or whatever.
the number, the frequency, or maybe we should call it frequency. Okay, so we probably ought to sort our data so we can do this, right? If you go to data and then sort A to Z, it's now sorted, okay? So we're going up to 1,000. So that is 26 right here, okay? And then we're going 1,000 to 2,000. And that is 28. And then we're going 2,000 to 3,000 because we don't like to count. We've got 11. 3,000 to 4,000, 3,000 to 4,000 is 20. 4,000 to 5,000. And that is also 20. 5,000 to 6,000. $26. Okay. Now what?
Now you highlight that.
Highlight this new table. What's this called, by the way? Data. Let's see, is that on here anywhere? Oh, I might need to add something on there.
Nathan stem plot. Spread on. Nope. That's not.
Oh, that's not on there. How did I forget that? Okay, we're going to add this to it. Okay, what? Anybody know what it's called before I type it? Say it again. So you're close. So what I've got there is a frequency distribution. Now, there's also a relative frequency distribution.
And when did we do that? What was that for?
When we created our histograms.
That's when we did the
That's when we did the relative. There's also, does anybody remember any other terms? There's a cumulative distribution. And there's a relative Cumulative distribution. Okay, so we're adding to this. Okay, so what have I got here? What did I create? That's a frequency distribution. How do I do a relative frequency distribution? Sorry, we're getting a little sidetracked from our histogram, but it's part of it. The fraction, okay. So I need to figure out the total. Now here's the thing that I want to remind everybody. It's on tape here, on video. Whenever you do a total, always leave a blank line. Now you don't have to, but those students who don't often make mistakes because then they get their total mixed up with their data. So auto sum, so I got 131 pieces of data here. And then how do I figure out the fraction? Equals 26 divided by 131. Now, do I want to use F4 on either of these? Yes, which one? The second one. Okay. So now when I divide that, hopefully these add up to what? What should they add up to? 1. Let's see if they do. Bingo, did it right. Okay. So that's a relative frequency distribution. What's a cumulative distribution? Okay, you just described the relative cumulative. Okay, so you said add up everything that's below. So this first one's exactly the same, right? Second one is going to be the one above plus the one to the left. Okay, so 19 and 21 is going to be about 40%. Does that make sense?
What are you adding?
We're adding the one above plus the one to the side. Okay, so the numbers between 1 and 2,000 adds up to be about 41%. Okay. Now that second formula, the first formula you don't want to copy, but the second one you can copy. And what should that up to? 1. Okay, I did it right. Okay. Now what's the cumulative frequency? The same thing, only with the raw numbers, right? So the first one's just 26 because there's nothing. The second one, tell me what to type, Olivia. What do you do, JC?
You do 28.
28 plus, we're adding them up. The one next to it, no, the one above you. Now, if you add this one, technically this first one won't matter, but what should it add up to? It should add up to 131. Did it add up to 131? No. Okay, so make sure you're adding the right one. You need to add the one to the left plus the one above you. And now, even though that 54 didn't change, when I add it up, it adds up to 131.
So it's going to be 11.
Yeah, 11 plus 54 is 65, right.
Then what was the relative cumulative again?
The relative cumulative is about the percents. The cumulative is just about the raw numbers.
So you do like the second one, 0.21 plus 19.
Yes, this one here. Okay. Now, what if I said I want a relative frequency histogram? How would you do that? Can't hear you.
I said you grab the relative frequency column.
You grab the relative frequency. Didn't you say crap?
No. I thought you couldn't hear me.
I know.
Oops.
I only heard part of it, but I think I reconstructed it. Okay, the relative frequency column, is that the only column?
No, all of the groups.
The groups column.
And the groups column. How do I get just the groups column without the one in the middle?
I don't know.
Control.
Hold the control key down, or you guys all, well, you're going to have to use control in the thing. You Mac people would do something different. I can't remember. Are you a Mac? Oh, you do? Don't you have to press command? I don't know.
I don't use Excel.
Yeah.
It's the worst.
All right. So yeah, press the control key. Now, what do I do? Casey, what am I doing?
You'll go up to
Insert.
and then find the graph.
Find the bar graph. Which one? Is 3D a good idea?
Never.
Never. I will. If it's worth 5 points, I will take off 10 if you put it to the 3D graph. The first one. Okay, and then what?
Press the green plus button.
You could do that, but there's something else you should do before the pressing the green plus button.
You have to combine.
Is this This is not a histogram. How do you push them together?
Settings.
Nope, not settings.
So click on
The quick layout right here. You press quick layout.
Oh, it's in the middle.
It's a good thing we're doing this review. I thought you guys remembered all this.
I don't remember.
You don't remember any of it? Okay. All right. Now, see, I didn't need to press the green button because it put this in here. What is this? What do we put down here? These are the groups of whatever it is. And this is what? Relative frequency. What would be another name? Percent. Thank you, Robert. Okay. Now, what if I wanted percents there instead of decimals? What could I do? Change what to percent? The axis? Or I could actually change this too. How would I change that to percent? If you go over here where it says general, you can change it to percentage right there. That's for your own knowledge.
Is there going to be a histogram on the final?
Absolutely. Maybe 2.
Oh, actually, that's fine. Give us two.
Wait, do we know how many questions there are?
No.
You said there were going to be 6 on the computer part.
3.
I did?
Yes.
3 to 6 is probably a good thing.
Perfect.
But there's gonna-
Fast, right?
So 3 questions with A through Z parts. How's that?
No. A through Z?
I'm just teasing.
A through E at most, please.
A through E at most. I don't know. We'll see.
I need to help.
Do you need to get your shift covered? I don't know.
If it's 6, that's like 6 hours.
No, I would plan on about
We're
2.
both not very smart at computers. Yeah, I don't do the drag and paste. I do each separate. Just to be safe.
Okay. Well, then it'll take you 6. Okay, Kristen. I can't hear you. Shh.
Do we have to go to the testing center for the computer part again?
Yes, you have to go to the testing center on Monday or Tuesday. Make sure you don't show up right before closing because you're only going to get an hour then. Okay? If you want more time, get there at least 3 or 4 hours before close if that's what you want.
Let's do a STEM.
Okay? All right. Did I answer all your questions?
So that's the same thing for
Are we done?
histogram.
No, we're done with the histogram though.
Yes, let's do the STEM plot now.
We want to do a stem plot. A box and whisker or a stem plot? Which one?
Don't you just highlight the data?
You can go back and watch the videos and he shows you how to make both.
I know.
So we can do other questions right now and you can go watch the videos.
What's your other question?
You want to cover
We can do a box and whisker. Box and whisker is easy, but I think a stem plot is good. What's the difference between a box and whisker and a stem plot?
STEM plot has only got
Stem plot has dots. Is that correct? No, that's not correct.
That's the
Or
one
like
where you
X's.
write. It's the one where you give like if you have like 26, you write 2 and then you put 6. And then
Okay, so here what we're gonna do. We're gonna do a stem plot here on not all the data because we got 131 data pieces, but especially since it's sorted. Okay. How would we want to do a stem plot?
you separate your
This is a bad data set for a stem plot because we have to go up to 6,000, right?
yeah.
So we might want to go 1, 2, 3, all the way up to 60. I probably would. Ah, yeah, it worked. Okay. So this is my stem, and these are my leaves. Okay. Now, the first number is 06. So here's what I would recommend. Put an 06 in there, because if you just put a 6, it's going to be confusing. You'll think it's 16, but it's 106. Okay? And then 124, and then 128, and then 129, and then 227, and then 243, and then 257, etc., 279. Okay? And then you're going to do 309, and I would put 09 here. Don't just put 9, put 09. Okay? Because if I just put 9, what number is that? It's 39. So it's 309. Okay? Etc. You're going to keep going there down to like the fifth. So let's go to do we have any numbers here? So if I went to 1031, so this would be 1031, 10, 11, well, that's it, 1031, 1151, 1209. Oh, that's interesting. 1209. And I would left justify these all. Okay. So that's a stem plot. How do we do a box and whisker? Oh, quartiles, we could do that. That's actually related, right? Which one do you want to do first? You have to do the quartiles to do the box and whisker. Okay. How do you do it on the computer?
Equals.
What are the quartiles? What?
Wait, don't you have to like find the mean?
The mean is not part of your quartiles. The median is, though. What are so we need your 5-number summary. What is your 5-number summary? What do they consist of? What? Minimum, Q1, median, Q3, and your max. Okay? And how do we find them now? Huh? I still can't hear you.
Oh, it is 106.
The minimum is 106 because you can see it. Okay? Yeah. Give me a break. Q1, how do I find that? Sure, how do you find the media? Add them up and divide them by how many there are?
No, that's the average, sorry.
That, oh, she said the A word.
You just go to the middle number.
You have to go to detention now. Go wash your mouth out with
I
soap.
did it the hard way. I just go like until I get to them.
Okay. So how do you find the median when you're using the computer?
There's a command for it.
Command, which is?
Equals
And we're allowed to use
average.
it.
It is average.
No.
No, I'm sorry, I'm so confused. Median, right?
It's median.
You highlight your data.
She wants to go to detention all day today, I can tell. The median, we're highlighting the wrong data here. This is our data. Okay, now let me show you something. Have I showed you this trick? So you highlight all your stuff. Oh, never mind, it won't work that way. Well, so median, that's one way you could do it. Now, there is actually a different way to do it, which I was trying to get you guys to do, but you skipped it to the median. How do you find the first quartile?
It's the median of the minimum.
It is the median of the top half, but there's a better command. Quartile, right? Which one? The bottom one. I want you to use the bottom one every time. Don't use the others, okay? Use the bottom one. Now you're going to highlight it just like you did on the median. And I'm going to show you a little trick, Dayla, so you don't have to spend 6 hours in there, okay? When you highlight your data here, press the F4 key right now, so it puts the dollar signs in there, okay? Then do a comma, and which one do I want?
The first one.
I want the first quartile. Now, if you put the dollar signs in there, that's going to help you, because now you can copy that to the others, okay? And you could have done it for the minimum too. Okay, now all I have to do is I change the 1 to a 2. 2 gives me the median. Okay, And then I changed that one to a 3. 3 is the third quartile, and I changed, except for I did it wrong. Let's see. And all right. And then the maximum is, I just changed to a 4. Okay. All right. So that's a good little trick. Okay. Or you can type it in every time if you want to stay there a long time. That's fine. Okay. Brock. Is there an outlier? That's a good question. Is there an outlier? How do you know? No? How do you know?
Just because I use my deduction skills.
She used her deduction skills. Say it again. Prove that there are no outliers. How's that? Prove that there are no outliers. How do you prove it? You do math. The histogram looks pretty good.
You do your first quartile minus the second.
Something like that.
Divided by. There's a number bigger.
What's that called? Interquartile range. Thank you, Brock. Interquartile range equals, what's the command? What's the formula? I think it should be on your sheet, but quartile 3 minus quartile 1. That's correct.
What chapter is this?
What chapter is this? I don't know. I don't remember.
2? No wonder I don't remember.
Yeah, that was the beginning of class. How would you expect me to remember that? So your interquartile range is Q3 minus Q1. So I've got a range of almost 3,400. Okay. Now, what do I do? Kristen? You missed a step. Yeah, but you were on the right track.
You're going to do Q3 plus 1.5 times the I.
There we go. Q3 plus 1.5 times the IQR. And what's the other formula?
Minus.
Q1 minus 1.5 times the IQR. Okay? So in this case, so Q3 is going to be that number, whoops, equals Q3 plus 1.5 times the interquartile range, which we found right there, and Q1 minus 1.5 times the interquartile range. What'd you say? Did I not? Oh, Q1, you're right. No, it won't work that. I don't know what I was thinking. That number there. Okay. Do we have any outliers? We have no outliers. Okay. Now, just for fun, what if my outlier was 125? What if my lower fence was 125? Would I have outliers? I'd have 2 outliers right there. Okay. All right. So we have no outliers. Okay. Now, how do we do the box and whisker? So I don't know. We didn't do any of those on our project. You should have, though. I think there was one group did them, didn't they? No? Okay, how do you do your interquartile range? Highlight your data. Insert. Here, let's go back up to the top so it's close there. Insert, then what? Recommended charts. Go to all charts. Go to box and whisker. Boom.
Did you just highlight? What did you? Sorry, I don't know the data. Just all of them.
Highlight your original data. Insert. Recommended charts. Go to all charts. Box and whisker. Oh, by the way. Oh, okay. And did you notice there Let's do that again. Insert recommended charts. You're going to see the histogram. It's illegal to use that. See what a crappy job it did? It didn't even make the bars touch. Usually it does. But look at those groups. Okay, compare those two. Which one looks better? Ours, easily. Like it doesn't even go up to 6,606. Like that's dumb. That's a dumb category. Okay. And do you see how different it looks? And by the way, we forgot to mention here, how would you describe that histogram? Bad? It's a bad histogram. Actually, we'll put that one over here. That's a bad histogram.
That's what I meant.
Okay? For one thing, the bars don't even touch. Why in the world? That doesn't even make sense. But how about this one? We'd call this one bimodal. Okay, does it look normally distributed to you? No. Is your n greater than 30? Yes. So remember, that's not a magic pill. Okay, you still have to check it. Okay? Bimodal, and it's certainly not normal. Okay, so I do want to emphasize here, just because your sample size is greater than 30 does not guarantee that it's normally distributed, because clearly that's not. But we wouldn't expect it to be normally distributed. Why? How did I come up with those numbers? Those are random numbers, and what do random numbers look like if you were to draw them? Random. Well, could you call that random? Is that a random number plot? When they're random numbers, right? What should a random number distribution look like? She did a bell curve. No, that's not true. Shouldn't look like a bell curve. It should look consistent. What do you mean by consistent?
They're all the same.
They're all a uniform distribution. And how would you describe that?
A box.
A box. It should look like a box. Okay. Yeah. Those first two actually look pretty close. Those two look pretty close to random. They're the same size. But yeah, it should look like a box. Okay. So even though we've got random numbers, it doesn't look like a box. Okay. And the funny thing is, even when we use theirs kind of looks. If these bars touched, I wonder if I can do that. Look, I made it touch. How dumb is that? It should make them touch, but I made them touch. So if this, okay, let's talk about this one. How would you describe that one?
Right.
That would be right skewed. Okay, now it's funny that we have the same data, but they use different groupings than we did. Theirs is right skewed, ours is bimodal. Okay? Would it change if we did, that's a good question. Would it change if we did the relative frequency versus the frequency? Would the shape change?
I feel like not really.
Feel like not really. Should we
I feel
prove
like
it?
It would keep its.
It would keep the bimodal look? Should we prove it? Prove it. How do we prove it?
Highlight the data.
Highlight the table. Okay, not the data. We want the table. Insert bar, 2D bar, make it touch. Hey, how about that? It's like twins, only what's the difference? What should I label this? I'll label this groups just like I did before. And what should I label this? Is that percent? It's not percent. Frequency, or I don't like the word frequency. What's another word for frequency? Count. Okay. So yes, your frequency histogram and your relative frequency histogram should have the same shape. The only difference is your scale. This is percents. These are raw numbers. Okay. We still haven't made our box and whisker. We did? I took it away? Oh, let's make it again. I don't remember. I don't remember how to do that.
Highlight all your data or your numbers.
Highlight, yeah, raw data this time.
You don't know what to use data.
Insert. Recommended. Oh, I guess we did do that. How did that? Why did I erase that? That's weird. There must have been a reason. Box. Okay, there it is. Now, is it labeled properly? There we go. We'll put it over there. These are what class? IQ scores. Would you like an IQ score of 6,000? If you had one, we'd know that it was not that high. Okay, and whatever. We probably should add. So I would get rid of this one because it's meaningless. But we should. Where's my plus sign? There it is. Now it's there. Add your axis titles. Let's call this the math 1040. And I don't know. Salaries. I don't know. I'm making this up. I don't know. It's clearly, it's just garbage data. Okay. You gonna ace my test on Monday? Monday or Tuesday? Monday and Tuesday? Who's taking them both on Tuesday? Wow, really? You guys are gluttons. Okay. Let's move on to the last 2 pages here. I think, well, sometimes they don't make you pay on the first day and sometimes they do. So I don't know what their rule is. That's their thing, not mine. Question. Correlation and regression, you want to do that instead? Is there anything you want to go over here?
Do a standard deviation by hand.
Correlation and standard deviation by hand. We got 15 minutes left. Do you want me to fly through it? Because I'll probably have to go pretty quickly in order to get both of them in. I can do it.
That's fine.
But you can watch this in slow motion and go, wait a minute, what did he do? Stop, start? Okay. So should we do correlation or standard deviation first? Correlation first? Okay, so I'm going to call this histo box plot. This is also your stem plot. Okay, so we're going to just do some random numbers because I don't like to come up with data. So this is going to be your X data. This is your Y data. Equals rand between. I'm not going to pick on Brock anymore. Ayla, give me a number. 1. And Casey, give me a good number. 80. Okay. How about Robert, give me a random number. Make it negative this time. Negative 50. And Olivia, 18. Okay. We're going to make these, we'll just do that many. We're going to copy, we're going to paste special. Paste special. There we go. Okay, so these are our numbers. Find the correlation, whatever, coefficient by hand. By hand on the computer. How do we do that? We need to find the means of each, right? Do I find that? Don't ask Olivia. She'll start swearing. We'll use the A word, and we'll curse Bill Gates as we do it, right? And the standard deviation. And we're not doing that by hand right now. We'll do that in a minute. Standard deviation. Okay, now what? That's all you know how to do? Do you remember what the formula is? Because I give you the formula. R equals sum of xi minus x bar over s sub x times yi minus y bar over s sub y all over n minus 1.
Hey, what chapter is this?
What chapter is this? I don't remember. Here, I'm going to write it this way. Okay? Okay, so you got that formula. Okay, we found our x bar, we found our s sub x, we found our y bar, we found our s y bar. What's our n? Let's throw out our n here. Is it 23 or 46? It's 23. Okay, here, we'll start hurrying. So I need to find my z-score for my x. So that's going to be xi minus x bar. I'm going to f4 that, and I'm going to divide it by standard deviation of x, which is 27. Oh, by the way, what should we be doing before we start doing our correlation? Should be drawing a graph, and the graph is called a, not a bar graph, not a histogram, scatter plot. Okay, insert scatter. We're going to start moving faster. Okay, there's our scatter part. What do you think? Does that look like there's correlation going on? Probably not. Okay, so we're probably going to expect very low or weak correlation, right? Okay, all right. Now I need to find the z-score for my y, which is equals yi minus y bar f4 divided by s sub y f4 that. Okay, I'm going to copy those down. Okay, now what do I do with these two things? I multiply them. So I'm going to take this times that, and I'm going to copy that down. And then I find the sum. And I know I'm going fast, but we're running out of time. Sum, and then I'm going to divide that by n minus 1, right? So I'm dividing it by 22 because my n is 23, right? I go, oh, wow, that's better than I expected. 0.494. How can we verify that our answer is correct?
Type in correlation.
Equals not correlation, but close. Coral. Pick your x. That's actually higher than I expected. Pick your y. Oh. So what would we say about that? Is that strong, moderate, weak, or no correlation? It's moderate. Surprisingly, that's moderate. So 0 to 0.3 is weak. 0 is none, right? 0 to 0.3 is weak. 0.3 to 0.7 is moderate. Greater than 0.7 is strong. I was thinking I'd get a negative correlation on that, but that was still positive. Okay. That actually makes sense now that I think about it. All right, so there's your correlation by hand. Oh, let's find the regression equation. That's a good question. How do you find the regression equation? By hand. Find regression equation by hand. Okay. So M, why it's so caps, M equals R times S sub Y divided by S sub X, and B equals Y bar minus M times X bar. Okay? So M equals your correlation coefficient, which we just found, times your standard deviation of Y divided by your standard deviation of X. Don't need them. This is going to be Y bar, which is that number, minus the slope that we just found times X bar. Okay, so what's the regression equation? Y equals 0.3504 X plus minus actually 28.818. How do we prove that?
You can find it on your chart.
Find it on your chart. How?
You just click one of the points.
Click a point, any point, right click,
No.
add trend line. That's your regression equation, or that's the line. And display the equation. You can also display the R squared on there. What would you say about the R? And that, we should add labels on here. These are days absent. These are test scores or whatever. More often you're absent, the better you get, right? Is that what happens? That's what some of you think. Okay. So look at that, 0.3504, that's what we got, minus 28.818. Look at that, we nailed it. Okay, what does your R squared mean?
The percent of variation.
Percent of variation, whatever, explained by the model. And in our case, we explain how much? 24%. Okay, do you think that's a very good model? 75% unexplained, right? 76%.
Standard deviation.
Okay, let's do standard deviation. We're going to pick the same point we got here. In fact, tell you what we're going to do. We're going to copy this. We're going to do it over here. We're going to paste it. We already know that this is the mean and the standard deviation, but we're going to do this by hand. Okay, so we already know the answer should be 27. Let's prove it. Do you know the formula? Sigma, or we're going to do S. There's two formulas, right? There's S and sigma. Which one are we using? We're using S equals the sum of to the square root of the sum of xi
Minus
x bar squared divided by n minus 1. If we were using sigma, what would we divide by? If we were using sigma, we would just divide by n, okay? When do you use sigma? When it's a population. We're assuming this is a sample, so we're using it. So S is what you're going to use most of the time, because usually we're going to use samples, but if this was a population, you'd use n.
Are you going to tell us?
No, I'm going to make you figure it out. Do you need, is this a sample or a population? I mean, I'll tell you it's a sample, and then you can decide, or it's a population, and you have to decide, oh, I use S or I use sigma.
Oh, okay, but you tell them the sample.
Yeah. Yeah. All right. So we got to hurry fast. Okay. So this is going to be data minus the mean equals this number minus the mean. That's fine. I'm going to copy it down. I'm going to square it. Oh, I did something wrong. I can already tell. Can you tell why I made a mistake? Can you tell I made a mistake?
Yeah, because they're the same numbers.
All of a sudden, we've got decimals and no decimals. Do you see that? The mistake I made was I didn't F4 that. Okay, now when I copy it down, now they're all decimals. See that? Okay, I did that because I was in a hurry. Equals that number squared. Copy it down. Find the sum. Add them up. I'm going to divide by n minus 1. My n was what again? 23? So I'm going to take that number and divide by 22. What number is that called? Variance. I'm going to take the square root. Square root of that, and hopefully it's 27.01793. I'm as smart as a computer.
You.
Okay, go ahead.
What things do we
Gentry.
need to F for and whatnot?
What'd you say?
Like what things do we need to F for?
What do you need to F for?
You don't want it to change.
When you don't want it to change. So in this case, the A26, I didn't want that. I always want to subtract the mean of 40.17. The first number I want it to change, so I leave that alone. Okay? So it all depends on the context. Okay? When I did this equation here, I wanted that to change every time, so I left it alone. Okay? We're out of time. We got 1 minute left. Is there anything on there you want to talk about in 1 minute?
You show us how to make it.
No, I will not show you how to make a pictogram.
Paradox.
What's Simpsons Paradox? Simpsons Paradox. Don't you remember when we talked about discrimination? You don't remember? Were you here that day?
She might have not been in class.
She might not have been. It seemed like you missed a lot of class on Simpsons Paradox. So we did it. Watch that video again because it's really good. We did a thing where this college, it looked like the women were being discriminated against. But then when we did the test, it said no, they weren't. And then we were like, how is that possible? And we went to the engineering department and it was equally admitted. And we went to the English department and it was equally admitted. So Simpsons Paradox happened. So the first numbers looked like women were being discriminated against. But then when you looked at each department, it wasn't true. And in some cases, not only is it not true, but the men were being discriminated against. And it's because you have unequal sizes. And so sometimes those associations can reverse when you break it down and look at it. So that's what Simpsons Paradox is. Question? No, all the equations you have are on the sheet. What would you want to bring that's not on the sheet? Oh, your steps? Yeah. No, I'll give you the equations. No note cards.
Can I
Okay.
have one of those? Everybody has one.
Well, these are my math. Are you sure you want this? This is math 2040 formulas.
You updated it, right? 'Cause they were wrong. It's got some stuff.
Well, that's got way more than you need. It'll overwhelm you. But isn't it posted up on the website? I'm pretty sure it's posted on the website. Yeah, just download it again.
Okay, cool.
I think the correct one's posted. I hope it is.
Thank you.
All right, you're welcome. So Monday, anytime you want on Monday, take the test. And I'll see you all on Tuesday, 9 a.m., right? Right here?
Yeah.
Okay. See y'all.